Hey everybody, I want to make a real quick video for you and let you see what we've been talking about in terms of our sine waves and the power coming out of the power plants and things like that. You've seen a lot of my slides on there, and this isn't going to give you an actual graphical display of the power coming out of our outlet. As you can see, I've got this is a Fluke 867 graphical multimeter, and it can measure voltage in both AC and DC, millivolts. It can read resistance, current, all kinds of things. It's just this gives us a graphical display and kind of gives you a picture of the cleanliness of the power coming through. Sometimes you hear about dirty power, and that's when sine waves are not real smooth for various reasons. There's sometimes interference and noises that come across those lines from other circuits, but this will give us a graphical display of the condition of our power and just the amount of voltage and everything like that. So I'm going to simply turn this on, and I've just got the red and black leads plugged into the outlet from the meter. It takes just a second for the meter to kind of initiate and boot up. Okay, and now she's ready to go. And as you can see, we're measuring about 120.6 volts AC. That's potential. That's the potential between the hot lead and its neutral. Okay, so that's the potential difference. But if you'll notice also, right under this 0.62 is a 60.03 hertz. Okay, that is the frequency at which the 120 volts of power is being supplied by the power plants that we're connected to the grid with. And so that is an actual number, and if you look to the left of that is an actual sine wave of the power coming through. Okay, the number this does not have 60 cycles packed into 1 second on that graph, but that's a snapshot of the condition of the power, and it shows you. And I can pull this lead out, and of course it goes flat because we're not measuring anything at all. Okay, this is just a little bit of a sine wave, just basically because the meter's got a lead that's open. Okay, but I can go back in there, plug it back in, and there it gives us our frequency. And you'll notice it's 60.03, which is about 2/100ths of a hertz, and that can be impacted by different loads here at the college, or somewhere on the circuit that's feeding the Brown Badgett Center. But I just wanted to give you a real quick visual illustration of the sine wave in action. And like I said, you can measure this right out of your home or your business or your brewery. But anyway, like I said, this is just another sample of ways to check our voltage and see the condition of sine waves and things like that. But thought you might enjoy that and find this kind of interesting. If you want to see the meter, just let me know, and we'll pull it out and let you take some measurements with it yourself. So we'll see you in the lab, and keep watching the lecture.